Okay, so today we're going to go through another special case of factoring polynomials. So remember, here's our map. This will be used for every single step of the way. So you have a polynomial. First thing you do is simplify. Make sure that there is nothing that needs to be combined or worked out. Rearrange it, put it in standard form, and then remove your greatest common factor. Okay, find the greatest common factor, remove it by dividing it. Okay, and then don't forget about it because it's still important, it's still a factor. Okay, so these are the three things that have to be done first. Now, a lot of times none of these will have to be done, but there will be times when you do have to do these things. So we always want to check for these three things first. All right. Okay, then remember that our what we're left with will either be a binomial, a trinomial, or a four-term polynomial. And so we did difference of squares last week. It's a special type of binomial. Today we're going to move into difference of cubes, another special type of binomial. Okay, so remember we're going to be talking about a binomial. Okay, and then the last thing to remember is don't forget, you always want to repeat the processes if you need to get everything factored out and always prove your answer. Okay, so we're going to use this and we're going to go through our notes. So you should have a set of notes. This looks like this. Here's your difference of cube notes. We always start with 3 steps. Always, always, always. Okay, you're going to simplify, you're going to rearrange, and you're going to remove the greatest common factor if there is one. Okay, now we know that this is going to be a binomial. Now, what's important is that we need to know how to tell if something is a difference of cubes, just like we had to know if it was a difference of squares. So there's some criteria that need to be met. So key descriptors, all right? We know it's a binomial. Difference, again, means subtract. Powers have to be divisible by 3 this time because we're talking about cubes. Okay, and we're also talking about numeric cubes. So we're talking about numbers like 1, 8, 27, 64, 125, and so on. Like 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. That's where I got these numbers from, okay? And what happens is if we meet all of these criteria, okay, then it's going to factor into 1 binomial and 1 trinomial, which is a little different than we've done in the past, okay? So here's that basic pattern that we talked about before. It's going to be a little bit different this time, and so it's going to be easiest to show you what this means when we do an actual practice problem and an example here. Okay, so one thing I want you to know is that when you're wondering about which sign to use, positive or negative, you're going to remember the acronym SOAP. We're going to do same, opposite, always positive. Okay, so SOAP. Same sign, opposite sign, always positive. Okay, so here's our example, and here's what we're going to work with. So we're going to break this. Here's our binomial. Okay, so first thing we do is check, does it need to be simplified? No, there's nothing to combine. Does it need to be rearranged? No, it's in standard form. Is there a greatest common factor that needs to be removed? No, it's already been done. Okay, so now we check. Is it subtraction? Yes. Is it a binomial? Yes. Are the powers divisible by 3? Is 9 divisible by 3? Yes. And are we dealing with a numeric cube? 64. Yes, 64 is 4 cubed. Okay, so we've met the criteria. We know that this is going to be a difference of cubes, and now we're going to split it into two factors, a binomial and a trinomial. Okay, so here's what we're going to do. The first position, just like last time was a square root, this time it's going to be a cube root. Okay, we're going to take the cube root of the first term. So cube root of m to the 9th is m cubed. So that's what goes right here. Okay, and to get that, all I did was I took the exponent and I divided it by 3, and that gave me m cubed. Okay, all right, now sign. I'm going to use here with the SOAP, same sign is what we're going to start with. Since we started with subtraction, we're going to use subtraction here. Okay, all right, let me move that back up so you can see a little bit better. All right, now in this position, we're going to also do the cube root. of the second term. So we did m to the ninth. Now we're going to do 64. So we're going to take the cube root of 64. And you can do that in your calculator. Let me show you how to get there so that you know. Okay. So under, let's see, math. Okay, hit the math button. That's this one right underneath the green one. You're going to scroll down to the fourth one. Okay, and it comes up as a cube root, and you can put in 64, and you find that the cube root of 64 is 4. Okay, so that's how we do cube root of a number on our calculator. And I already showed you how to do cube root of an exponent. Okay, so cube root is 4, so that's what goes here in this position. All right, now stay with me. This is going to be a little bit different from last time, because last time we had two factors that were pretty much the same thing. This one's going to be a little bit different. So here, we are going to square what we're going to call a. Okay, so remember up here in our pattern, this was a cubed. We took the cube root to get a. So now we're going to square that. Okay, so whatever we have here in this first term of the factor, we're going to square. So we're going to take m cubed, and we're going to square that. And remember, when we raise a power to a power, we multiply those. So it's going to be m to the 6th. Okay. Then for a sign, we did same sign. Now we're going to do opposite sign. So it was subtraction. Now it's going to be addition. So we're going to do opposite sign. Okay. Now, the middle term, we are going to multiply a times b. So this is a. If you look at the pattern, this is a, this is b. We're going to multiply those two things together. So we're going to do m cubed times 4. And we would just rewrite that as 4m cubed. So 4m cubed goes right there. Okay? And then we use, the final sign is always positive. So this goes here, and it is always positive. Okay, so same sign, opposite sign, always positive. And in the final spot here, we are going to square the b. Okay, so we squared the a already, now we're going to square the b. So 4 squared is what we're going to do, which is 16. Okay, now here's where we need to check ourselves. Okay, it says to repeat the process if powers are not 1. Right? Well, if I look here, powers here are not 1. So we need to double check and make sure that this is not also a difference of cubes or a difference of squares. So we check, it is a binomial, it is subtraction, the powers are divisible by 3, so it could be a difference of cubes, but this number right here is not a numeric cube, so we're done. We can't go any further. Okay, so this one is done. We've done that part. Now we need to prove our answer. And remember, to prove it, we just take and multiply these factors back out. So that means we take m cubed minus 4, and we multiply it by m sixth plus 4m cubed plus 16. Okay, and we're going to multiply that. So we do m cubed times m to the 6th, that's m to the 9th. Then we're going to take that m cubed and multiply it by these other two terms as well. So m cubed times 4m cubed is 4m to the 6th. M cubed times 16 is 16m cubed. Okay. Then we take our negative 4 and multiply it by those three terms. So negative 4 times m to the 6th is negative 4m to the 6th. Negative 4 times m cubed is negative 16m cubed. And negative 4 times 16 is negative 64. Now we combine our like terms. 4m to the 6th and negative 4 becomes 0. 16m cubed and negative 16m cubed also becomes 0. And what we're left with is m to the 9th minus 64. And that's what we started with. Okay, so that tells us that our factors are correct. Now here's what I want you to remember again on this. What's important to remember is that this is not your answer. Okay, this is where you checked your answer. Your final answer in factored form are these two factors. that's the answer that we're looking for. We're not looking for the where you checked it, we're looking for the final answer, okay? Now, instead of doing partner work here at the bottom, what you're going to do is 4 practice problems, okay? So I want you to do e cubed minus 8. I want you to do y to the 6th minus 27. I want you to do 3x plus 81x to the 4th. And I want you to do y to the 12th minus 343. Okay, now a couple of things to remember. On number 3 again, you're going to have to do some work here. Not only are you going to have to take out a greatest common factor like we did last time, but you're also going to need to take and rearrange it because it is not written in standard form. Okay, so be careful about that. You want to rearrange and remove the greatest common factor on this one. So let me put you a note down here again. So rearrange and remove the greatest common factor on this one. Okay, so keep that in mind. Now you're going to complete those 4. Send them to me. Let me check them. Make sure that you're on the right track. And if you're doing okay, I'm sorry, didn't mean to move that. And if you're doing okay, then I'll go ahead and give you the go-ahead to do the practice problems as well, okay? So here on this next page are your practice problems. There are 5 of them, all right? I want you to be careful about these. They are challenging, so you're going to have to think through these. Make sure you start with simplify, rearrange, and remove GCF every time, okay? This one will be pretty straightforward. So will this one. This one shouldn't be too bad. You are going to have a great common factor on this one. Down here, you're going to have to do some rearranging, so be careful on that one. And down here, I think you're going to have a greatest common factor and need to rearrange. Actually, just a greatest common factor on this one, okay? So just be careful, all right? So take your time on these 5 problems, and then when you're finished, you can send them to me to check. And if you have any questions, make sure you let me know, okay?